Okay, so the YouTubers are on. TikTokers are not on as yet. They're gonna take the whole evening. Okay. Now, I realize that the students who are on YouTube, they are seeing me, but those who are on TikTok, they are not seeing me. So, what I'm going to do, I'm going to start. But first, before I start, I think that the students who are on YouTube, you're not privy to the cause of the late start. As a matter of fact, the traffic that I encountered this afternoon, let me tell you something. I imagine that I would not have class, but I say I'm going to push it for 7 o'clock. Alright, so I say I'm going to push it for 7 o'clock. When I left, because I was dropping my daughter home from school, so I encountered the traffic on my way home, dropping my daughter home from school. So I said, all right, let me give it a few seconds and then return. When I attempted to return, believe me, the traffic that I encountered was worse than the one that I saw on my way home. So instead of coming to the office directly, I decided to drive downtown. So I decided to go through the town instead of just come directly to class. When I got downtown, it's a good thing that I did not have to go through the middle of the town. Believe me, you have people who are stranded right at this moment, cannot find their way home, cannot get a means of transportation to go home. And I saw some individuals walking home. And I don't see what really caused the traffic in terms of this side of the city. But the flow, the individuals for flow, they are doing some work somewhere, outside of the town. And I saw them, and I really realized that that would probably cause some serious buildup of traffic. So I think that that's the cause at the moment. And it's really, really, really very, very, very bad. Yes, so if I didn't know this city inside out, believe me, I would still be in traffic. So I have to apologize to the students who are on YouTube Live at the moment, because I think that you are the only ones who are alive at the moment, because TikTok is giving me an update thing that is maybe going to take another few minutes. Now we started with the trinomial, and of course the ones that we did or we worked with before did not have a coefficient of anything apart from 1 here. So the coefficient was 1, and then we just wrote down the 2 factors. As a matter of fact, later on you will be cultured how to look at any trinomial, no matter what it looks like, and be able to write down the factors. But to take it in stride here, what we intend to do is resolve the middle term into its 2 components. And in order to do that, we need to multiply these 2 numbers. So we're going to say what 2 numbers multiply to give a positive 24 and add to give 10. And those will be the 2 coefficients of the middle terms. And then after resolving the middle term into its 2 components, then you will have the expression. Instead of being in trinomial form, it will be in quadratic form. And when it is in quadratic form, you factorize by grouping, of course, taking 2 at a time. So we're going to say what 2 numbers multiply to give 3 8s, 24, and when you add them, you get 10. So 10 is your result. So those 2 numbers are 6 and 4. 6, 4, 24. And when you multiply 6 and 4, you get 24. And when you add them, the result is 10. So it's a little bit of a continuation or an expansion of what we did quite recently. So you just need to make that final step. So 3 8 24. So we have 3x squared plus, maybe you want to put the 6 first, 6x plus 4x plus 8. And you are going to factorize that by grouping, taking 2 at a time. So you're going to say what? What is common in 3x squared and 6x? So you're going to have a 3x there. And 3x into 3x squared, the x is left. The 3 into 6 is 2, and the x's will cancel. And of course, you need to put the 4, the plus there, the sign that begins the second pair before you factorize the second pair. And that's a 4 right there. So you're going to have x plus 2. And of course, you know that the common factor is x plus 2. And then the other factor will be 3x plus 4. So at this stage, there's no teaching from the grassroots up, because you can factorize by grouping already. Well, you should be able to factorize by grouping. And of course, we know how to resolve. We know how to arrive at the 2 middle components, because it's pretty much what we have been doing with the first set of trinomials. So the next thing that we do is this. 3 tenths, 30. What two numbers multiply to give 30? And when you add them, the result is 17. They multiply to give 30, and the sum is 17. Of course, those two numbers are 15 and 2, x squared. So it's 15x plus 2x plus 10. So the two numbers multiply to give 3 tenths, 30, and when you add them, the result is 17. Those two numbers are like that. Right. What do you mean no sound detected? Okay. Okay. All right, so it's good that everyone is coming on now. Yes, students, so I was just erasing the answers that I have, because the YouTube students were on a long time ago. It is just that TikTok took a bit of time to get going. So that, I was just a little bit held up by the app. Right, so I'm on now. And of course, I would have started the class over more than 10 minutes ago, I would have started the class. So now I have to restart to accommodate my TikTok students. Also, the camera that I have positioned in the classroom, the cameras that I have, the one that is on YouTube, don't show these bright lights. I see this bright spot, you don't see that on YouTube. Right? Well, you'll probably see this one. Maybe not. You don't see those on YouTube, but you'll see them on TikTok. So what I'm going to do, I'm going to switch over the lighting. So I'm going to turn on the other light so that your view will not be so much obscured. Okay, I see a little patch there. Let me see now. It's a little bit better. All right, so we are ready to go. Now, we are stepping up to the next level of trinomials, and I'm hoping that we can finish this in as short of time possible because we are over an hour late. Now, yes, I discussed with these individuals on TikTok because of the lateness, and then I also communicated to the students on YouTube when I got in because they were here ahead of time, so I don't need to discuss that with them anymore. All right, so let's go. Now, notice now for the trinomials that we are going to, that the coefficient of the square term is not 1. There's a number here apart from no number. Of course, when there's no number there, the coefficient is 1. But now there's a number, so this number is 3, and so now your coefficient of x squared is 3. Now it's just a little step up. And as a matter of fact, you shouldn't have any difficulty because all that you're going to say now is that the two numbers multiply to give 3 times 8. So that's 24. So the two numbers, the product will be these two. Instead of the product just be 8 alone, in which case the coefficient here was 1, so it's 1 times 8 is going to be 8. Now it is going to be 3 times 8. So it's going to be 3 8, 24. So you're going to do the same thing. What two numbers multiply to give 24, and when we add them, the result is 10. The sum is the same. So give me that. The two numbers multiply to give 24, 3 8, 24, that's the product, and the sum is 10. What two numbers multiply to give 24, and the sum is 10. Let's go. Of course, I'm soliciting answers from the individuals who are on the live. Let's go. Two numbers multiply to give 3 times 8, which is 24, and when we add them, the result is 10. I need those two numbers. I see them, 6 and 4. Early, thanks. So 6 and 4, and I'm going to put them there in the same order that you have given them to me. So now we have what? 3x squared. Here we have a 10x. The 10x is comprised of what? Plus 6x plus 4x. And of course, your final term is 8. So there's your quadratic. So your expression now is in quadratic form, whereas it was still quadratic, but it was a quadratic in trinomial form. Right? Yes. So this quadratic is in its pure and original form. So when you see an expression like this, and they say that this is a quadratic, sure it is. It is a quadratic in trinomial form. Why is it a trinomial? Because it has two middle terms that are like terms. and those two middle terms are combined to form one term. So when these two middle terms come together, it gives you the 10x. And that is why, although it is originally, and it has all the characteristics of a quadratic expression, the form is not quadratic here. It's trinomial. But when you find the two middle terms, and you write them down, and you have the expression like that, it is in the quadratic form because you have all four terms. And of course, we are going to go straight into it. What are we going to do? We are going to factorize by grouping again, students. And that is why everything that you learn, you have to revise, you have to rehearse, you have to reinforce, all of that in order that when you go to the next thing, it will be that you can continue. Because if I need to come to trinomial and teach you how to factorize a quadratic, the course will take 10 years to finish. Because it means that everything that I teach, when I'm ready to move to the next one, I have to teach everything again. Alright, so here you go. Your factorization by grouping. We know how to factorize by grouping, so we go straight ahead. Now, I'm going to ask you for the first pair, what is the common factor of the first pair? The first pair is 3x squared plus 6x. What's the common factor of the first pair? If I don't get the correct answer first, I'm still going to be delighted to see your answer. I'm going to be happy to see your answer. 3x, and it is correct. All right, so 3x. Of course, for these two, 3 is common in 3 and 6. And x is common in x squared and x. So I do, the 3 is common for 3 and 6. And the x is also common. What do? I see here, we're going to divide this term into this one. So the 3 will cancel, as you will see, and x into x squared is x. What next do we see? 3 into 6 is 2. And then the x's will cancel. Do not forget, students, your basic factorization is that you find the highest common factor, and then you do what? Divide each term by the highest common factor. And I see a lot of students answering 3x, 3x, 3x. You're all correct. What about x? Is x correct? Well, x is a common factor, but x is not the highest common factor. The person is neglecting the coefficients here. And when you're attempting to find the common factor, you have to give the coefficients also consideration. So you cannot just look at the letters and symbols alone. And notice that I'm not saying variable, right? Because I didn't say that's a variable, the x is a variable. No, it might not be a variable. So don't call it a variable unless you are sure. All right. Okay. All right, so we see somebody asking me for Cornwall Mego. Yes, I attended Cornwall College when Cornwall College was the premier mathematics school in the whole western hemisphere of the earth. Yes, when Mr. De Bruin was our teacher. What do I do to find Mr. De Bruin book? He's somewhere around there. So we have a book, oh, there it is. So that is Mr. De Bruin there on the book cover. And that is Harrison House of Cornwall College. So you'll see the Harrison House of Cornwall College, and you'll see Mr. De Bruin. So of course you'll see, and you could see in the writing, the red and gold. So you can tell that it's a Cornwall College mathematician, it's a Cornwall College book, it's a Cornwall College picture, it's a Cornwall College mathematics experience. Yes. And I won the national mathematics competition 4 times consecutively for Cornwall College as a student, and I went back to run it again as a teacher. Yes, so for you to know that I'm really off the stock. Yes, for Cornwall College, when Cornwall College was the greatest mathematics institution in the whole Western Hemisphere as any high school. It's not that now, no. Cornwall College is very, very far from being that now, but it's not my fault because I have all of the resources that Cornwall College needs. Right. Yes. So on my team, you have people like Richard Mayu, Trevor Cameron, Richard Reed. You have Lloyd Ellis, Leighton Walters, Krishna Sitaram, myself, Richard James, Lindley Jarrett, Everton Robinson, Peter Lichmore. There's a ton load of us. Brett Cobham. Yeah, so I remember a lot of those students who were on the same mathematics team with me. Yes, and when I attended university, the whole Caribbean and the Jamaica, of course, knows that once you attend Cornwall College, when it pertains to mathematics, they need to align themselves with you. Right? Yeah, so they know that they need to align yourself with you. So when I was in like my physics class, to my right was yes, Nigel Clark. Yes, the Minister of Finance. Nigel Clark's sister was on my left side. She sat right here. And Stacy Knight sat to my right, but in the row just ahead of me, just in front of me. She was just right here in front of me, to my right. But Nigel Clark's sister was sitting exactly beside me, on my left side. I couldn't figure that because I'm left-handed and because when I'm writing, because of how close she is and she's right-handed, sometimes our elbows usually hit each other and all of that. Yeah, so, and in the physics class, it was P.J. Patterson's son who was the lecturer in physics at the time. But we have a lot of different lecturers in physics, but that particular course that we were sitting beside each other. Right. Right, so she was there right beside me. Okay, so you're not surprised that I won the National Mathematics Competition 5 times. Yeah. All right, so let us continue. Of course, what we did, we resolved the middle term into its two components, and we are factorizing by grouping, and factorization by grouping is something that you all should be familiar with already. And students, don't, all right, let me just tell you what. The factorization by grouping, I think that I have 10 audiovisuals on factorization by grouping inside of the TikTok, what do they call it? Studio, not studio. Profile. So if you go on my profile, you'll see the last few animated audiovisuals. 10 or so of them are factorization by grouping. So you cannot be at a loss if you follow me on TikTok and you do what you are supposed to do. Because I'm not only here teaching factorization by grouping, giving your homework on factorization by grouping, return on a Sunday to solve the problem on factorization by grouping, but they are also in my profile and the videos are there, and it's not just one of them, it's 10. And I think that I'm going to put maybe 2 more up there. And then I'm going to put the difference of 2 squares. So you'll have a lot to occupy your time if you want to go and learn something in the meantime. Yes, I'm going to be posting them up. And whatsoever other videos I have, because I have 77 audio visuals in that little section. I have more, you know, because you know that I always have more. I have a lot. But in that section, I have 77 to post. All right. So let's continue. So remember now, like in your factorization by grouping, the sign that begins the second pair goes first. So the sign that begins the second pair goes first. And then what is common in 4x and 8? What do we see is common in 4x and 8? I see somebody do it already. So what is common is 4 right there. And what do we do? We're dividing 4 into 4x. The 4's will cancel and give you x. And of course, 4 into 8 is 2. Then your common factor is, see, you can see that x plus 2 is your common factor there. X plus 2 is your common factor. X plus 2 is your common factor. And then the other factor will be 3x plus 4. 3x plus 4. And that's all there is to that one. Now, of course, we have quite a few more to do. We have this one. And of course, we are going to resolve the middle component, the middle term, sorry, we're going to resolve the middle term into its two components. And we are going to do that by saying 3 tens. So 3 tens, 30. What two numbers have a product of 30? What two numbers have a product of 30 and a sum of 17? They have a product of 30 and a sum of 17. Of course, we're going to still have our 3x there, 3x squared, and we're going to have our 10 down here, same way. The two numbers have a product of 3 tens, 30, and a sum of 17. For the students who are just getting in, you did not miss a thing, because I was stuck in traffic on my way, bringing my daughter home from school and also getting here after that. So we are not far gone. 15 and 2. Somebody's saying it's 15 and 2. Yes. So what I'll do, I'll put the 15 and then put the 2. Alright, so we're going to have the two components will be plus 17x will be 15x plus 2x. There we go. And then what do we do? Factorization by grouping. What is common in 3x squared and 15x? What is common in 3x squared and 15x? What is x? Oh, that's nice. That's a nice question at this stage of the game. 3x. Somebody's saying it's still 3x. Let us see if it is still 3x when we get here. Alright, yes, it's 3x. So the common factor is 3x. 3x. And what do? We say 3 will cancel 3 because we're dividing each term by the common factor. 3 into 3, well, 3 will cancel, and x into x squared is x. Then 3 into 15 is 5. And then the x's will cancel. And we are finished. Next, what do? What is common in 2x and 10? I think that we have it on the board already, no? What is common in 2x and 10? I know that I will see that in a few seconds, maybe less than 5 seconds. 2. Thank you very much. So 2 is common. So we write our common factor as 2. And what do we say? 2 will cancel 2 and give x plus 2 into 10 is 5. And what do we say? The common factor is x plus 5 and the other factor is 3x plus 2. Now students, if you have been, internalizing the course so far, then we would not have any difficulty at this stage, because resolving the term into its two components is a matter of finding the two numbers that will give the product and also give the sum. And we know how to do that already. Also, the other part of the factorization is factorization by grouping. So if you know your factorization by grouping and you know how to work out the two components from the sum and product, then we are on. So it is not a new thing that we are inventing. It's just a continuation of what we did before. And here we go again. In this case, what do we have? 2, 3, 6. The TikTok students would not see that because of the position of your camera. 2, 3, 6. So the two numbers have a product of 6 and a sum of negative 5. That's a twister, You'll see that in the twister coming up later on. 3 times. Come on. So the two numbers have a product of what? 6 and a sum of -5. What two numbers have a product of 6 and a product, so it's have a product of 6 and a sum of -5. What are those numbers? Maybe you didn't hear what I said. When you multiply them, the result is 6. There are two numbers. When you multiply them, the result is 6. When you add them, the result is -5. There are two numbers. When you multiply the two numbers, the result is 6. When you add them, the result is -5. The result is -5. You know that I'm not going to accept that. All right, the person who said 2 and 3. 2 plus 3. What is 2 plus 3 equal to? Yes, and what is 3? Is 3 2? Yes, what 3 and 2 equals? When you add them, when you add 3 and 2, what is the result? So I see 3 and 2. Oh, -1, -5. 5. Yeah, but you said that when you add them, the result is 5. But what is the result is supposed to be? Students, you are just wasting time if you neglect the sign. You are just wasting time. You have to consider the sign. So now that you know that the sign is negative, what must the two numbers be? Somebody is saying 6 1. -3, -2, yes. You're supposed to come in and say something, you're gone. Somebody's saying 1, 6. -1 with -6. What will that give? Students, you were warned. Yes, you were warned. You were warned, students. Make sure you master directed numbers. But no. No. When I say master directed numbers, no. I don't have to listen to what Mr. James is saying. All right, then follow me. Since you didn't have to listen when I say master directed numbers, you must be able to follow me on your own now. All right. Well, I did. Yes. All right. No, you're saying that it's a long time you haven't seen me in 7 and a half. But I was not there to stay. I was not there forever. So those who envision that I would still be there, see what happens? You have to take the opportunity when you get it. So when I'm there with the mathematics books and they see it, they just buy it. If not, then this will happen to some individual. All right.
Sir, may I send a -3 and 2, sir? May I say a -3 and 2?
This is what you just said, you know. You said it is -3 and 2. That's what you said. Will that give -5?
Yes, sir. No, -3 and -2. That means it.
You have to say what you mean. This is not love.
We're gonna add
This is
them.
mathematics. Yes, you have to say what you mean. Of course, that's correct. Let me put them the other way around then. -3x minus 2x. That's right. The negative 1, negative 6 would not be right because for your directed numbers, when you add numbers with the same sign, you add the values. So you're going to add the values and the answer will take the same sign as the numbers that you have added. So that will turn out to be a negative 7. And that is why negative 1, negative 6 is not right. But I'm sure that there are other permutations of the numbers and signs that will give you a 6 and a 1, but surely not with the same sign. But we'll see that later on. And we'll see that in other topics, apart from factorization of trinomials. You'll see that in solution of quadratic equations. And you quite likely will see that when we are solving a pair of simultaneous equations of which one is linear and the other is quadratic. So students, stock up on your skills. So stock up on your skills so that when we move to the next one, yes, stock up on your skills so that when we move to the next thing, you will be able to follow. All right, so let's go. We are factorizing by grouping. Right, we are factorizing by grouping. Let's go. What's common in these two? What's common in these two?
So X.
Just X alone here. X is common here. So, let me write
My first two, sir.
like 2. Right, 2. So, we have X is common. Nothing to cancel the 2 goes back. X into X squared is X. Then we move to the next one. Nothing to cancel the 3, it goes back. And the X will cancel the X, and that's all, so we're going to close that bracket. In the mode of factorization by grouping, you put the sign here. The sign that begins the second pair is what you put first. Right, so you put that sign that begins the second pair. What's common in these two? So what's common in these two? What can you see is common here?
Nothing, sir.
Right, you don't see anything that is common.
That's
So when you don't see anything that is common, you say that the common factor is 1. Because of course, 1 is always a common factor. If there's nothing else will work. So 1 is the common factor. So what will happen now? Nothing to cancel the 2, it goes back. Nothing to cancel the X, it goes back. Do not forget that when you're dividing, you have to divide sign and all. So negative into positive is negative. And of course, you know that 3 divided by 1 is 3. Do notice that negative into positive is negative. Do not force the 2 brackets to be the same, because you will get cases in which you will not do what is required for them to be the same, and at the same time you put them to be the same, and you will make a meal of the problem. And then the other factor is X minus 1, as you can see. Now, what do we have here? And what do we say? We say what? 2 times 15. This is the last one in this set before you get some more to do. So those will be for you to do. Get ready. So we say what? 2 times 15, and that is 30. 2 times 15, that is 30. What 2 numbers multiply to give 30? And when we add them, we get a negative 13. They multiply to give 30, and when you add them, you get a negative 13. What are those 2 numbers? Students, capitalize on this because this is the easy one. Later on when you get the twisters, they're not going to be so straightforward. What two numbers multiply to give 30? Because it's 2 times 15. What two numbers multiply to give 30? And when you add them, you get a negative 13. Negative 10, negative 3. Yeah. Right, so 2x squared minus 10x minus 3x plus 15. Alright. Why do we say that? We say that because they multiply and the result is positive. The result is positive. They therefore must have the same sign. They must have the same sign since the result is positive. Next, the sum is negative. So since they must have the same sign, then the two of them must be negative. Student, mathematics is a subject that requires you to think and reason. So you always have to be prepared to think and reason. Don't imagine that information will just go in your brain like that and you just reproduce it. You have to do some mixing of it for yourself. And of course, we are going to be your factorization by grouping. And I see the answers coming. Yeah, I saw them before. Where did I see 6 and 7? If you multiply 6 and 7 will give you a negative 13 if you are using a negative 6 and a negative 7. You get a negative 13. But when you multiply them, you will not get 30. So if you use 6 and 7, a negative 6 with a negative 7, you will get a negative 13. But when you multiply them, you are not going to get a positive 30. So let's go for the common factor here. I expected someone to go ahead of me with the common factor. What's the common factor? 2x squared minus 10x. What's the common factor? I'm going to write it now. You used to say that it is 3x. What do you say that it is now? (2x). I'm going to take that first one, 2x. 2x is the common factor. And we're going to divide each of these by 2x. So we're going to say what? The 2 will cancel the 2. X into x squared is x. Then what do we say next? 2 into 10 is 5. 2 into 10 is 5. And x will cancel with x. And then you close the brackets. What next? What is your common factor here? 5, negative 5. Take a second go at it. I know what you mean, you know. I know that you did not mean any harm. Negative 3, thank you very much. You have to put the sign, students. You need to put the sign. I'm going to write that like a negative 3. And then you're going to divide. Of course, negative into negative is positive. That's always the case for there. And then nothing to cancel the x, it goes back. Do not forget that you're dividing sign and all. Negative into positive is negative, and 3 into 15 is 5. Yes. So what do we have now? X minus 5 with 2x minus 3. If you missed out on your factorization by grouping, students, we have countless other visuals for you to watch. They are there. One class, well, it's not one, but it's not perfect. And that is why we have other resources that you can make use of. Now it's your time Yes, so it's your time. And you're not I think that we have 7 problems. I'm going to give you 4 now. And then we're going to do the one with large coefficients next. Let's go. I'm not going to put them here. I'm going to start over there. So, students, you know how to resolve the 2 middle terms. So that's nothing new for you, students. Additionally, you know how to factorize by grouping. I have 10 factorization by grouping audiovisuals on TikTok for you to watch, apart from the fact that I did it in class, gave you homework and solved the homework problem. So, what else can I do? Somebody is saying hello. I'm saying hello to you too. I'm delighted to have you. Welcome and have a good evening with us. Thank you for popping in. Welcome to the live experience. All right, so let's continue. I'm going to put yours on the board now. I'm going to take my, do I take my old? I'm looking for my old. Yeah, here it is. Yes, I'm looking for my old manual. So I'm going to put the ones on the board that I intend for you to do. I'm going to write the numbers, so I might skip a number or two. Number 1. What is number 1? 3x squared minus 7x plus 5. 3x squared minus 7x plus 5. 2. Where is it? 2x squared plus 13x plus 15. 2x squared plus 13x plus 15. That's your favorite. Students, if you practice many trinomials, they can hardly give you one in the exam that you have never seen before. Start working on those. Yes, because I'm going to go to the board with them in a few. And I shouldn't be hesitating to erase the board because you have everything documented. Three. 3x squared plus x minus 2. 3x squared plus x minus 2. I'm going to put 4 and see if it will work. No, it's 5. 5. 2x squared minus 5x minus 3. I love this one. 2x squared minus 5x minus 3. So those are the 4 that we're going to be doing. It's the exercise. This was... Alright, let me tell you where it is at. But for me to do that, I will have to go into my new manual. For the students with your new manual, it is page 19, exercise 4.6. So yes, it is page 19, exercise 4.6, and it's the same ones that we're doing now, the ones that I have on the board, those are the ones that I'm going to be doing. Yes, those are the ones that I'm about to do. Let's go. Anybody finish number 1, say yes. You cannot tell yourself that you are not at that stage. Remember now that I have 12-year-old students who pass the exam. So unless you're about 10 years old, you're not at that stage. So you have to rise to the occasion. You have to lift your game. You have to rise to the occasion. So you cannot you cannot solve those problems. I put them on the board for the students to solve them, and you cannot solve them. You must imagine that in a few seconds, I'm going to be explaining them on the board. So you must learn something. So I put 4 of them up there first, and I work them out and I explain. I explain all of the concepts, and we do the resolving of the middle coefficients, and we did the factorization by grouping. Then now I put 4 more. The students are required to do them. Whether or not the students do them, whether or not they get them right, I'm still going to explain them on the board. And after that, we have large coefficients. And I'm going to explain the large coefficients. And I'm going to work them out on the board. Then after that, we have the twisters. I'm going to put the twisters on the board first and give you the opportunity to solve them. If you cannot solve them, or those who solve them, whether they solve them right or wrong, I'm going to go to the board again. Now tell me, after all of that, you will not be able to learn? Come on, you cannot convince me. Yes. I'm sure that it has to be 2. So there you go. And I'm going to look if there's any more for any other. Which one do I look at? 2x squared minus 7x plus 5. 2x squared plus 13x plus 15 is okay. 3x squared plus x minus 2. And 2x squared minus 5x minus 3. 2x squared minus 5x minus 3. Yeah. All right. Let's go. All right, so let's go. This one is straightforward. 2 5s 10. The two numbers multiply to give a positive 10 and add to give a negative 7. What are they? So I know that some students are onto that already. They multiply to give a positive 10, they add to give a negative 7. What are they? If you did not get the correct answer, then you would not ask me a particular question. So I know that you are correct, and I know that you are doing it right. Yeah, of course, the AC method. You're saying, why can't you comment? But you're commenting. So what do we have? 2x squared minus 2x, according to what you say, minus 5x plus 5. So we're going to go with that. Well, you can make a request and I will invite you in. So the other person is, well, that are in. So let's go. All right, so let's continue. You're factorizing by grouping. So you have decided, or you have arrived at the conclusion that the two middle components are negative 2 and negative 5. Those are correct. So we have 2 5s 10. That's a positive 10. And the sum is negative. When the product is positive, we are sure that the two numbers have the same sign. So when the sum is negative, since the two numbers already must have the same sign, we are sure that the two numbers must be negative. And we have a negative 2 with a negative 5, and we're going to go straight into our grouping. So what do we say? What's common in the first pair? 2x squared minus 2x. That's a nice factorization right there. If I don't see it on the screen, I'm going to write it in myself. So we have 2x is common. 2x is common. Of course, you can see the 2's cancelling, and x into x squared is x. Negative. Of course, you're going to see that we're dividing 2x by 2x. Any number or expression or term divide by itself, the result is 1. So that's a 1 right there. Now we move to the second pair. Alright, we are moving to the second pair. We are looking for the common factor of the second pair. So let's go. The common factor of the second pair is what? I'll give you a few seconds on this one. What's the common factor for the second pair? Not only the 2 cancel, but the x will also cancel. 2x into 2x. The 2 will cancel, and the x will also cancel. The second pair was, I'm looking for the common factor. Yes, I see that. A negative 5. Students, you're not doing what you're supposed to do. You're not putting in the sign. A negative 5. Let me write that. Let it look more like a 5. And then what do you know? The 5 will cancel in the first case to give you x. And do not forget, negative into positive is negative. And then the 5 into 5 is 1. And then your common factor will be x minus 1, and your other factor will be 2x minus 5. Let's go. Your next pair. So what do we say for this? We say 2 times 15, that's 30. I'm sure that's not the first time you're seeing 2 15s 30. And then the sum is 13. So 2 times 15, that's 30. What is the two numbers that will multiply to give you 30? And when you add them, the result is 13. So the product is 30 and the sum is 13. Product is 30 and the sum is 13. I know that by the time I look on the screen, I will see the two of them. I'm looking at this. The second one is 2x plus what about this one? One is saying is 15-1. The two numbers have a product of 30 and a sum of 13. A product of 30, 2 times 15, 2 times 15, that's 30, and a sum of 13. All right, so I see a negative 2 and a positive 15. I see a negative 2 and a positive 15. Then I see a 2 and a 15, and so on. But let me go back to it. I see 310. I see 310. Students, you cannot have a trinomial. You cannot have a trinomial with all terms positive and give me a negative number in the result. Because if you are going to give me a negative number in the result, where will the negative number come from? When all of the terms are positive. So let me take a look and see before it scrolls off the screen. Yes. So it's going to be what? I'm going to put it in the same order that you give me, 310. I'm going to put it 310, although that is not what I wanted. I wanted to put it 10, 3. So 2x squared plus 3x plus 10x plus 15. So the middle term, which is 13x, is 3x plus 10x. And we will take the first two. What's common in the first two? I'm just going to put the brackets alone. What's common in the first two? Alright, no answer yet. What's common in the first two? Alright, by the time I get over here and back, I will see. Alright. X alone is common. X is common. So X is a common factor. Nothing to cancel the 2, it goes back. X into X squared is X. X into 3X, the X will cancel, and we have the 3. We put the Alright, you are saying 3 and 5? Alright. Maybe you're looking at the 15 alone. But at the same time, when you add 3 and 5, you do not get 13. And you're saying 3 and 5 because of the 15. But you need to, in this particular case, the coefficient of X squared is not 1. So you need to multiply the 2 that you have here by the 15. So it is 2 times 15. So the product is not 15, but 30. 2 times 15, that's 30. And what's the common factor here? Plus 5. I'm going to put that without looking. Oh, that's a nice question. That's a beautiful question. So what do we say now? 5 into 10, that's 2. Nothing to cancel the x, it goes back. 5 into 15 is 3. And of course, we can see the common factor of what? 2x plus 3. And then in other parentheses, we have x plus 5. All right. Now, how do we know what to go inside in the middle? What to go on the inside? I'm thinking that you're just joining, because this is the 6th such problem that we have done so far. Yes, I think that you're just joining because this is the 6th such problem we are doing so far. So let us go to this one. And of course, we're going to do the same thing that we have been doing all along in order to get the number that go on the inside. So I'm going to give you the opportunity to take a go at this one. Meanwhile, I put in my 3x and my negative 2. What will go on the inside? If you do not consider the signs as well as the numbers, then you might run yourself into a little problem right there. You got the same answer and you didn't do it like that. Then there is no restriction, right? There is no law that what I do on the board is universal and it cannot be done another way. So if you have another way, another mathematically legitimate way of doing it, use it. Don't be tied down to one way of thinking. Alright? So, don't let my way of doing things dominate your culture. So if you have a mathematically legitimate way of doing it, then you don't have to do it like that. Alright, so let's continue. Let's continue. So let us do this one. We are going for the two numbers. 3 times negative 2. Right. 3 times negative 2. When we multiply 3 by negative 2, we get negative 6. So the two numbers have a product of negative 6 and a sum of positive 1, because 1 is the coefficient of the x that we have right here. So we are saying what two numbers multiply to give you a negative 6, and when you add them you get a positive 1. What two numbers? You are familiar with this from last class, and you know that this is what we call a model problem, where the coefficient here is 1, or negative 1 is a model problem. And you should figure out the answer in a second. Negative 2 plus 3. Sure, it is negative 2 plus 3. Because, first of all, the product is negative. Because the product is negative, the two numbers must have different signs. Right. So, the problem really is, what two numbers have a product of negative 6 and a difference of positive 1. And when they have a difference of positive 1, the two numbers are consecutive, like a 2 and a 3. And of course, when you're putting together the sum for two numbers with different signs, the answer will take the same sign as the larger one. And you learn all of those already. And I keep repeating them every day. So all of these, there's nothing new that I'm saying today. There's really nothing new. So someone told me, and I think that you gave the negative 1 first. You give the negative 2 first. I'm going to put it in the same order that you gave it to me. I think it's a negative, so this is square. So it's negative 2x plus 3x. Right. The factorization now appears as if you are going against the grain. But that's still fine. What's common in 3x squared and negative 2x? What's common in 3x squared and negative 2x? 3x squared and negative 2x. What's common? I just see that let me look before I write. Just the x is common. The x alone is common. Well, we're dividing the x into this term. There's nothing to cancel the 3, it goes back. X into x squared is x. Then what will happen? The x will cancel with the x and give you a 2. And of course, thank you very much. You need to go to the next one immediately. What's common in these two? Get there before I do. Get there before I do. All right, no answer so far. What's common in these two? One of the students will say there's nothing common. And of course, when there's no notable common factor, the common factor that you choose is 1. But you have to write the sign that begins in second pair, so it's a positive 1 that you're going to put right there. And of course, 1 into 3x, anything divided by 1 is that same thing. And of course, it's positive into negative, so it's at a negative 2 same way. So, of course, a negative 2 that goes like that. And of course, when you're finished, your final answer will be 3x minus 2 with x plus 1. So we arrive at the 2 middle term by finding the two numbers which, when multiplied, will give the same product as this, which is in this particular case negative 6. So they give you a negative 6 for the product and a positive 1 for the sum. Let's get here. Again, the product is negative 6. And on this occasion, the sum is negative 5. So let's see what you make of this one. You're going to find two numbers which will give you a product of negative 6 and a sum of negative 5. A product 2 times negative 3, a product of negative 6, and a sum of negative 5. I'm going to wait for you on this one to see how well you will. It's 6-1, of course, it is 6-1. Yes, that one is 6-1. So this one is what? Let me see which one you put first. You put the 1 first. I'm going to put the 1 first. Plus x minus 6x. And put it negative a little bit closer. So the two numbers that will multiply to give you a negative 6, and when you add them, you get a negative 5. The two numbers are a positive 1 and a negative 6. And we may factorize. What's common in these two? I was giving you a few seconds to make your decision, but you have done that very quickly. So the common factor is x. Nothing to cancel it to, it goes back. And x into x squared is x. And of course, in the end, plus x into x is 1. The factor of the next pair must have the same sign. So we're going to begin with the same sign that begins the second pair, which is a negative sign. So we'll have a negative sign right there. And let me see if there's anybody with the answer yet. 2. I don't think that you meant 2x. I think that you're making mention of this 2x plus 1. But we are a little bit beyond there now. Yes, we're a little bit beyond there. Alright, so let me put that in since there's no one going for it yet. The common factor with this and this is a 3. A negative 3. So of course the negative signs will take care of each other there, and 3 into 6 is 2. And nothing to cancel the x, it goes back. Maybe that is the 2x you're telling me about, but I wanted this first, the common factor. And then finally, the common factor would not be 3x because x is not in the 3 right here. So x is not here. So this could not have a common factor of 3x because the x is missing here. So x could not be in the common factor. Alright, so let's continue. Do not forget, negative into negative is positive, and then 3 into 3 is 1. And your common factor is 2x plus 1, and the other factor is x minus 3. Now students, we have done 8 to come on students, we have done 8 of them. Students, we have done 8 of these problems. So many? Alright, 8 of them. And I think that you're going to have a few of them to watch when we get there, because we're going to put in the what I call it, difference of two squares first. All right, so let's continue. We are going to look at the large coefficients. When you think that the coefficient is large, you can just multiply these numbers 3, 2, 6, 2, 3, 6, 2 times 15, 30, 2 times 5, 10. But what do you do when you think that the coefficient is the coefficients are large? So we're going to take a look at something that you can do. You don't have to follow me 100% on it, because you might be able to devise a method, and maybe your teacher will give you another method, and the textbook will give you another method. So we're going to be taking a look at the large coefficients. I don't understand that question. So let us take a look at the large coefficients. When you think that the coefficients are large, what do you do? If you think that the coefficient is large, what do you do? So we're going to look at the first one that has a proposed. I'm not saying that the coefficients are large, because for some students it's large, for some students it's not large. But if you think that the coefficients are large, you may do this. And some students, because I say that if the coefficients are large, then after now, all of the coefficients are large. Yes, you take all of the coefficients as if they are large. So if they ask you 9 times 5, you're going to put it in the same method that I'm using now, because you are thinking that that's large. Don't use it, well, if you want to use it, you may, but use it only when you think that the coefficients are too large and you couldn't figure out the numbers. So if you are overwhelmed by the coefficients, let's do that. We're going to take a look at number 4. Number 4 says what? 3x squared minus 8x minus 28. 3x squared minus 8x minus 28. When you think that the coefficients are large. When you think that the coefficients are large, it will benefit you to go back to primary school. Like how it benefits me, because I'm always going back to primary school. I'm always going to primary school. So take a look at this now. First of all, let me ask you a question. What two numbers are you going to multiply? This is your trinomial. You're attempting to find the little coefficient. What two numbers are you going to multiply? So I'm soliciting an answer for that. What two numbers are you going to multiply? Eight and 3. All right. So the two numbers that we're going to multiply will be 8 and 3. So those are the two numbers that you're going to put in the table. So your table will be like this. And I'm sure that you remember this table from primary school. It's not 8 and 3. It's 28 and 3. The two numbers that, oh, that's why you're not doing it so right, because you're saying it's 8 and 3. No one is saying it's 3, 4. Some say it's 4, 7. Some say it's 4. The two numbers that you're going to multiply when you're trying to find the middle term will be 3 and 28. My volume is down. Well, it looks like that. But I hope that you're hearing me still, because I don't know what they've... Alright, so let's go. So what do we do? Do not forget that we are focusing on these two numbers. These are the two numbers that you are multiplying, and those are the two numbers that you're going to focus for the table. So now that we have those two numbers, what do we say? 2 into 28 is what? 14. Then we say 2 into 14 is 7. Then we say 7 into 7 is 1, and we close that part of the table. The next number that we're going to multiply is a 3. So it goes there. It's just a single number with a single factor, single prime factor. 3 into 3 is 1. So these are the numbers that you're going to use. So we have 2 times 2 times 3 times 7. We are putting them in numerical order. And what we want from that numerical order, or that product that we have there, we want the two numbers that will give us what? The same product as 3 times 28 and the sum of negative 8. So, of course, it is 3 times negative 28, and the sum is negative 8. So we have to use the combination from here. In your combination, you cannot leave anything out, and surely you cannot put anything in. So you will have to use all of these numbers, the 2, the 2, the 3, and the 7. Nothing more, nothing less. If you use anything more or anything less, it is not going to have the same product as 3 times negative 28. So now, I'm going to choose a combination. So my combination is 2 times 2 is 4, and 3 7 is 21. So if I use 4 and 21, I will not get negative 8. No. If I use that combination, I will not get negative 8. So what I want you to do, I want you to identify the combination that will give you the negative 8. Let's go. My combination I chose did not give me negative 8. I chose 2 times 2, then 3 times 7. That would not give me negative 8. So when I choose this, I get a 4. When I do this, I get 21. I will not get a negative 8 by using that combination. So I want you now to choose a combination that will give me the negative 8. Let's go. Let me see if there's anyone with it as yet. Let's go. Let's go. Give me your combination that will give you the negative 8. Let me give you a few seconds. My combination did not give negative 8 and could not give negative 8. So I'm looking for your combination that will give me a negative 8. Let's see. Did I not just tell you say you can't leave out none of the 4 number already? Alright, so whether or not, let's go. Alright, so what you will have is 3x squared minus 8x. The combination that will work will be 2 times 7 and 2 times 3. So that will give you a negative 14x plus 3x plus 6x minus 28. Students, you better pay attention this year. Next year when I come on, I will not be watching your comments. I will not be looking at the comments at all. I will just be going on the board and just do what I'm doing and then leave. So you have to grasp opportunity with your 2 hands. And those who try to joke this out and try to clown out the class, I'm sorry if you don't pass mathematics already. Because when TikTok locked down, I will still be doing what I'm doing, what I used to do and what I want to do. Because TikTok cannot stop me from doing what I want to do. So those students who are clowning out and trying to clown out the class, go and clown it out. As if CXC mathematics is a big deal. It's a big deal for you if you don't pass it. But I was doing calculus when I was 14 years old. So you better take this one serious. The common factor here is x. So we have 3x minus 14. Then the common factor here will be a positive 2. So it's the same thing after you have resolved the term into its 2 components and you have the quadratic form. You factorize by grouping in the same manner. Same factorization by grouping. The common factor here is 2. So 2 into 6x is 3x. And then 2 into 28 is 14. So the common factor is 3x minus 14. And then the other one will be x plus 2. Let's take a go at another one. The class was probably double this. 30 is now 30. Maybe it was 60. Well, that's good because we're going to have only the interested student remaining in the chat. And I'm just going to finish up. After this, we're going to have another set. So let's go. The next one is number 6, which says 10x squared plus 19x minus 15. Again, the two numbers that you need to multiply are these two numbers. So those are the numbers that you're going to consider as candidate for the table. Let me take it from this side. All right, so I'm going to put the table all the way over there. So we have the 10 right there. The two numbers that we're multiplying are the two numbers that we're going to try to find the factors of, to express as products of their prime factors. So we say 10. 2 into 10 is 5. And then 5 into 5 is 1. We are accustomed to this table from primary school. Then the other number is 15. And then we are going to choose, where you know that 2 is not going to work, so we use 3. And then 5. Then 5 into 5 is 1. So we're going to put them in numerical order. So the 2 and the 3 will go first. So we have 2 times 3 times 5 times 5. And let's see who can figure out what the two components will be. So that's your set of prime factors. Well, I can see on my sound graph. Let me see if. I hope it's louder now. Let's go. Can anyone figure out what the two middle components should be? Three times 5 times 5 times 5. So we need the two numbers that when you use the combination, you'll get a sum of 19. Of course, you have to consider the two signs that we have here. What are the two numbers? What combination will give you 19? Let's go. Alright, so 25, 6. That looks right. So a negative 6 and a positive 25. Let me see if you have the correct signs there. Yes, you do. So we have what? Negative 6x plus 25x. Excellent. And let me look if it's going to into, no, it's not going into the light. So what do we have now? What do we have? The common factor here is 2x. 2 into 10 is 5. X into x squared is x. 2 into 6 is 3. And the x's will cancel. Plus, what's common there? In the 25 and 15, 5. And then 5 into 25 is 5. Nothing to cancel the x, it goes back. And finally, 5 into 15 is 3. So what do we have? 5x minus 3 is the common factor, and 2x plus 5. Students, I use something known as the building block approach when I'm teaching. I use something known as the building block approach. Before you can manipulate algebraic expressions, you must know indices and you must know directed numbers. And when you're manipulating directed numbers, you multiply and you divide. When you go to factorization, if you cannot multiply or divide algebraic expression, you cannot factorize. And if you do not know directed numbers, you cannot factorize. Then when you reach to the factorization and you reach to the trinomial, if you do not know your directed numbers, you cannot get the middle coefficients. And of course, when I started factorization, I did factorization by grouping. As a matter of fact, before factorization by grouping, I did basic factorization. You cannot factorize by grouping unless you do basic factorization. When you get to trinomial, you cannot factorize this unless you can factorize by grouping. And you cannot factorize by grouping unless you can do basic factorization. So do not imagine that you can jump in the middle of the class and figure out what is going on when we have so many subtopics and topics that are requirements before you get to this stage. And if you are just joining, do not believe. I don't know why you think like that. Because if you think like that, you're not prepared to do a mathematics exam. If you arrived at the class late, whether in terms of time of arrival in the particular class or in terms of where we are at in the course, and you imagine now that I will have to go and do the same that I've done when you were not here. I have to do it over. How can somebody think like that? Then if I do that for you and do that for the next one who's coming and do the next one for that means I will never complete a single topic for the entire year. You don't figure that out? Try that next year. If I'm around next year, try it. The final one that we are going to be doing for a large coefficients will be 6x squared plus x minus 35. Nice. Number 7. 6x squared plus x minus 35. You are going to break this one down for yourself. Let's go. When you are through, I just want to see the two middle coefficients. So you're going to attack it and then break that down and let me take a look at the two middle coefficients. Let's go. No answers yet? All right. Let's go. 10:15. For this one, what are the two values? Okay. All right, the class started. Let us just cause this to be the last one for today. We'll do the twisters on Thursday. So, anybody with the final answers for that? I see that, 1514. Excellent. So we have what? 6x squared plus 15x minus 14x minus 35. How did we arrive at that? We use the 35. 5 into 35 is 7, and then 7 into 7 is 1. Then what do? We use the 6.